Thanks for the introduction. Yeah, I work as a cloud platform engineer, and my role primarily focuses on cloud infrastructure management, infrastructure automation, SRE, and cloud security. So I'm going to talk about how infrastructure as code and GitOps can go beyond the infrastructure automation and enhance the security in multi-cloud environments. So by just codifying the infrastructure and applying the GitOps principles, we can enforce a declarative governance, maintain consistent security policies across cloud providers, and we can also automatically detect and remediate any misconfigurations or configuration drift. Uh, and this approach not only reduces the human error, but that builds a foundation to enforce continuous compliance and rapid threat detection. So I will walk through how we can implement IaC and GitOps with Argo CD and Crossplane to create a declarative policy-driven workflow. So where the infrastructure resources are defined as code, stored in Git repositories as a single source of truth, and continuously reconciled against the live state of the multi-cloud environments. So this is the agenda for today. We'll talk about the challenges in multi-cloud management, IaC and GitOps, and how we can leverage Argo CD and Crossplane to build that pipeline, the reference architecture, and the end-to-end workflow, and much more. To start with, like the challenges in the cloud infrastructure management. So now, like almost every enterprise adopting the multi-cloud strategy. So to increase the resilience and avoid any vendor lock-in, and also for innovation, right? So they use services from AWS, Azure, even GCP based upon their requirements. So the ability to use the best services from different providers that helps avoid vendor lock-in and creates that flexibility. So, but that also creates a challenge because every cloud has their own identity systems. They have their own APIs and own policy frameworks. So instead of having a single unified control plane, so organizations can end up managing multiple services, multiple tools, standards, policies for each cloud environment. So what are the challenges that they can face here? So like, for example, like configuration drift. So what are the changes applied manually or inconsistently across cloud that can lead to mismatched state? The second one is like operational overhead. Here, like our teams, the application team or the platform team can spend more time to manage multiple tools or multiple processes. And the third one is like lack of visibility, like having multiple cloud environments can create like incomplete observability setup that prevents a clear end-to-end view of across all this policy fragmentation. So here, like we have the different policy enforcement models and guardrails for each cloud that can lead to inconsistent governance. And at last, like slow threat response. So when an issue comes up, like we take some time to determine, and then we may get like end up in a situation to collect the data and then take some time to review and then address that issue. So so in short, like the multi-cloud provides the agility, and resilience, but if we don't have like a governance model, so it can create a complexity, risk, and slow response time. So we talk about like IaC and GitOps. So IaC and GitOps can address multi-cloud challenges through declarative definitions in version control systems to manage both infrastructure and applications. So IaC defines the infrastructure like networks, VMs, or databases in declarative code templates that ensures consistency by defining the infrastructure as a software. And GitOps, like it takes one step further. It uses Git as the single source of truth, and tools like Argo CD, we can use it to deploy continuously and make sure what's running on the production matches what we define in Git. So if something drifts away, like if someone makes some changes in the infrastructure level, it gets the cross plane automatically reconciles and restores the resource what we have in the Git environment. So together, IaC and GitOps provide a declarative automated way to manage both infrastructure and applications across clouds. So that helps reduce human error, and it also strengthens the security and governance. Yeah. So talk about Argo CD, that is actually a GitOps operator. So it is a Kubernetes GitOps operator for managing the application and infrastructure deployments. So at its core, it works by continuously syncing the desired state, what is stored in Git, with what actually deployed in the live environment. So that means like the entire environment is defined declaratively as a code, version controlled, and always aligned with the code committed in Git repositories. So this approach gives us like automated, auditable, and repeatable deployment workflows. So we don't need to code things like multiple times. So even if we want to perform a rollback, we can use the templates what we have to restore the infrastructure. So it also enables the advanced capabilities like drift detection when something changes unexpectedly. We can enable that rollbacks if something goes wrong. So next one is a Crossplane. It acts as like a universal control plane for multi-cloud or resource management. So it enables a Kubernetes native approach for provisioning and managing the cloud infrastructure. It also provides a unified API that can be used to communicate with AWS, Azure, GCP, on-premise resources for effectively managing the resources across the environments. And it also can integrate with the GitOps tools like Argo CD. So when we store the code in Git and deploy them through GitOps tools like Argo CD, we can enforce like declarative, automated, and drift-free governance. So, for example, if an infrastructure resource in prod or in a live system doesn't match what we have in Git, so Crossplane automatically reconciles it, or what we call like it tries to restore or reconfigure the resource what we have in Git. So this eliminates the configuration drift and reduces the need for any manual intervention. So we have OPA Gatekeeper along with Argo CD and Crossplane. So this acts as a policy as code engine to enforce policies and implement security guardrails. Um, so before Crossplane provisions a cloud resource, so OPA Gatekeeper is placed at the Kubernetes API level. It evaluates each cross-plane composite claim. I mean, we'll talk about this later, against set of policies. So it's like a checkpoint. If something is, if that a request or a configuration file or is like doesn't follow the policies, or it's like not or non-compliant, then the OPA gatekeeper removes that resource, and yeah, and it does not allow the cross-plane to provision those resources if they are not compliant. So this is a reference architecture for to build on multi-cloud architectures with Argo CD and then the Crossplane. So both Argo CD and the Crossplane runs on Kubernetes clusters. On the left side, we can see the GitHub repositories. We have the infrastructure code or stored under GitHub repositories. Under Argo cluster, we have the Argo events, Argo workforce, and Argo CD for creating a CI/CD pipeline. We'll talk more about that. And on Crossplane cluster, we have the open agent policy agent gatekeeper, and then the Crossplane deployed here. And yeah, on the right side, we have these targeted clusters. So when a developer initiates or requests something to be created, so the request placed in Git repositories, and then the Argo cluster watches for the commits or the code, and then it fetches the updated code, and it runs the CI/CD pipeline, and then it sends to the Crossplane. It sends to the open policy agent for verification before the Crossplane deploys that resource onto the target environments. And we also have a HashiCorp vault to store the some of the confidential data like credentials or any secrets. So this is the end-to-end workflow. When a developer initiates a Git PR, like a developer asks for like some storage or database needs to be created, he places a values.yaml file with the requirements under Git, and then under the code repo. So the Argo, and in the Argo events, like always, like it looks for the any Git commits that happen on the code repo. It fetches the code and it analyzes, and then it triggers the workflow. So under the Argo workflows, we have the build and test. So the build process like collects the inputs from the values.yaml file, and it builds the XRC, or what we call like cross-plane composite resource claim files, and then it uploads those composite resource claims onto the deployment repo. So now Argo CD picks those XRC files for the deployment on the cross-plane cluster. So yeah, Argo CD like fetches the XRC files from the deployment repo and sends to the cross-plane cluster where we have the OPA gatekeeper and then the cross-plane install. So the OPA gatekeeper, evaluates the XRC files and checks with the predefined policies and checks whether the resources are compliant. Whether they follow the constraints or the whether they are compliant or not. And once if it finds like if the resource is compliant, it sends to Crossplane for deployment. If not, it terminates that request from the Argo CD. And the Crossplane, we have the XRD composition XR. We will talk more on this as well. So the Crossplane picks up the XRC files and process that for deploying the resource like the database or storage onto the target environments like AWS, Azure, GCP, and on-premise. So what is the key feature of this design? So now, with this architecture, we can implement a GitOps control. So the desired state declared in Git. So the Argo cluster pulls, and then the cross-plane reconciles. So rather than just being like only for deployments, we don't need to use cross-plane. You can also use it for the reconciliation purposes. And then we can also implement the policy as code guardrails, like we can use the OPA gatekeeper to enforce the compliance before any resource gets created. And also we can implement the platform as code abstraction. We use the XRD compositions and composite resources to deploy the resource as a package. And also we can even use this design for multi-cloud portability. We can use this for AWS, Azure, GCP, on-prem to create like multi-hybrid cloud platform. So we need to talk about these components of the Argo. So I talked about the Argo cluster where we have the Argo events and then the Argo workflows. So the Argo events, like it is kind of an event-driven automation engine. It contains the event source, event bus, and sensor. It listens for like signals like Git commit, webhooks, or CI triggers. So once it detects an event, for example, like a developer commits a code onto the code repo, it triggers the workflow. It triggers a workflow on like Argo workflows. Even it triggers the workflows on GitHub Actions, or even you can use it for Jenkins. So that initiates the build process. So next, the Argo workflow. So it is also like a Kubernetes native workflow engine for running the continuous integration pipeline. So it runs multi-step job directly inside the Kubernetes cluster that validates packages and then generates artifacts for deployments. So in this case, in our Argo CD and Crossplane, so it builds and tests the composite resource claims based on the infrastructure requests that we receive from the developers or the application team, then pushes those built packages into the deployment repository for deployment. This one is like GitOps apps, so app of apps pattern that we need to follow for the Argo CD. The app of apps pattern in Argo CD is a way to organize and manage complex deployments by using we will only have like one parent application that manages multiple child applications. So instead of loading every app application directly into Argo CD, we can create a single parent application and that deploys multiple child applications. So this makes it easier to group services, enforce consistent structure, and scale GitOps across teams and environments. And also with this pattern, every child app has its own Git repo and lifecycle process, but everything is still controlled by the parent app. Yeah, this one for a cross-plane composite resource claim, XRDs, and compositions. For under cross-plane, we have these three components like composite resource claim. So it is a claim request submitted by the developers or application teams. So the developers or the application teams, they don't need to know about the cloud infrastructure. They can simply submit a request. They can ask like, so I want to provision a database, or like they need they can say like they need a storage. So on the cross plane, translate that request into a code to provision the requested cloud resources, the database or storage. And XRD or like composite resource definition. So it defines a schema on API for the infrastructure resource claim. So they standardize how resources are exposed to application teams or developers. And also it makes it easier for the platform teams to ensure consistency in provisioning and managing the resources. And plus the compositions. So they are like a template for creating multi-cloud resources into a single composite resource. For example, if we need to create a database, RDS database on AWS, for RDS database, we require a VPC, subnet groups, DB database parameter groups, and other resources as well. So we can combine every other resources into a single composite resource. So it reduces the what to say the yeah it helps us to automate things into a single resource, and we can also easily manage it. Yeah, there's a code snippet for cross-plane XR, I mean, the composite resource claim and composition. So under composition, yeah, this is how we, there's example code. We define like what needs, it's actually like a blueprint or a template. It contains, this composition is for creating a database, a Postgre database. So it contains like what subnet group needs to be created, what, what version for the database needs to be assigned. So we have this as a template, and XRC is kind of a request, like the developers raise this, and they ask for like what version of the database needs to be provisioned, what is the size of the database. So they they can give the requirements through XRC or like the infrastructure resource claims. And this one is for the OPA gatekeeper. So there are two things like constraint template and constraints. So the template defines like what are all the resources or what are the policies that can be implemented. So here with this template, like example, this one is configured to allow specific composition templates. So if some other if a developer wants to provision it, something that is not allowed, it gets terminated. So there's a organization, there's a Git repository, like the code repo and the deployment repo. Under code repo, we have these clients, we have the prod and stage environment. And here under this path, the developers or application team places their values.yaml file, their requirements under the deployment repo structure. Once the values.yaml file are built into the XRC or the infrastructure resource claims, they are placed under the environments folder. So under platform folder, we have the manifest files for Crossplane, manifest files for Gatekeeper, Vault. So everything is codified. We maintain the configurations of Crossplane, Gatekeeper, Vault, Argo CD in terms of code in the Git repos. So what this architecture offers us in terms of drift detection, real-time cancellation, and threat mitigation? So under like end-to-end drift detection, so at the Kubernetes layer, Argo CD constantly checks if like whether the running or the provisioned resource matches what's defined in the Git repositories. If something drifts away, it flags as an out-of-sync resource. So it alerts the application team or the platform team to resolve that issue. And at the cloud layer, Crossplane keeps watching. It keeps on watching the external resources like databases or networks. So if someone makes changes onto that database or networks, it detects it, and then it performs a reconciliation. It brings back the configuration, what is there in the Git repo. So under real-time cancellation, so Argo CD is not about like spotting that drift. It automatically heals it. Like we can enable like auto sync feature or self healing feature. So it restores that configuration from Git. And also the Crossplane, it reconciles the resources that was provisioned on the target environment, and also it enables the resources on AWS, Azure, or GCP to align with what we have uh, in that code. So it actually it continuously checks for the resources and maintains that the compliance, and then it actually safely handling the retries and the cleanup process. So for threat mitigation, so if someone makes an unauthorized change or violates any policy, the alert, we can make some alerts to trigger to go to the on-call persons or on-call teams, and they can initiate some auto healing process that reverses those changes. And so we can make the infrastructure fully auditable, and make the code changes reverted back to what we have in Git. And on the prevention side, like we follow the shift security left process. So everything like apps, infrastructure, and policies is defined declaratively, and it is reviewed through pull request. So and also we have this OPA gatekeeper to enforce the compliance before even like the cross-plane provisions that resources. And that is one feature of Crossplane. It enhances the security by using the short-lived credentials, and it uses the scoped rules for each cloud provider. Like we need to install like provider configs for AWS, Azure, or GCP to support their environments. And also we could also talk about how far back secret management and then multi-tenant isolation can be implemented using Argo CD and Crossplane. So under our back, so Argo CD uses the app projects to limit which repositories, clusters, or namespaces a team can access. So no other teams, so no team can access another team's pipelines. And in Crossplane, we leverage Kubernetes RBAC. So the platform team owns the definitions and the configurations. And while the application teams just create the claims on the Git repo, for provisioning any resources. Yeah, and for secret management, we don't store any secrets directly in Git. Instead, Argo CD retrieves them at during the sync time using the tools like Argo CD Vault plugin or external secrets operator. So if encryption in Git is required, we can use SOPS. Not sure about that full form. And for Crossplane, that integrates the secrets with Vault. So we use the Vault to store the secret confidential data, especially the AWS credentials or Azure or GCP and under Vault. So the Crossplane uses that secret data to communicate with AWS, Azure, or GCP. Yeah, so for multi-tenant isolation, so in Argo CD, each tenant gets its own app project with a dedicated service account role. So we can restrict what resource types, we can limit the cluster scoped operations, and even define sync windows for safer rollouts. In Crossplane, each tenant or account is tied to its own provider config. So the composition for creating the composite resources, it selects the right provider through labels of parameters and deploys the resources on the correct platform, like either it's AWS, Azure, or GCP. So how observability, auditing, or compliance reporting is achieved in this architecture? So Argo CD continuously tracks or desired with this live state, and it enables the real-time visibility. And it also provides it also audits the trails through Git history. So with the Git history, like we can determine like when the code was updated, and what we have in Git, whether it's reflecting on the target environment or not. And Argo CD and Crossplane exposes the metrics or logs via Prometheus or Hotel. Um, so we can use like Grafana and even like alert manager configurations to trigger the alerts. And we can use Grafana for dashboards across AWS, Azure, or GCP. Um, so I mean, the one note I want to indicate is that the GitOps workflows like ensure every change is versioned, traceable, and policy driven to support the compliance requirements. So at last, like we talk about the future directions and what are the advanced capabilities that we can implement with this architecture. So now, first one is the federated universal control planes. So instead of running isolated cross-plane instances, we can federate them. So this allows us to create multiple control planes across regions or even across clouds that reduces the load onto the current environment. So if the, for example, if the infrastructure grows on AWS or Azure or Crossplane, so relying on one particular cluster can increase the load onto that particular cluster. So we can create multiple cross-plane clusters to manage that load. And we can also define composition functions and pipelines. So we can at reconcile time, so they automatically add cost tags, enforce the network baselines, or even it applies the encryption. So they allow us to orchestrate resources declaratively and also applies the compliance. So it can even perform the operations of or the tasks of the OPA gatekeeper. And you can also implement AIOps for GitOps. Here we can leverage AI agents that uses the LLM models. They can look for the pull request to create the artifacts, and also they can look for any drifts that occur on the target environment. This we can use the AI agents to automate multiple steps within this GitOps pipeline. Yeah, at last I want to talk about the hardening Git resources. So we can lock down the Git by requiring signed commits and tags. We can even pin those with SHAs, and even we can enforce branch production. So the mutable Git tags don't make it into production, which reduces any compliance risks. Thank you.